So this is lesson 6. It's something we need to do today, and you need to get this done before I see you on Wednesday. It's graphing trigonometric functions, specifically graphing sine, cos, and tangent. They are graphs that are known as periodic functions. A periodic function is a function whose graph repeats regularly over some interval of the domain. The length of this interval is called the period. Physics students, I'm sorry, there's another variable that's called the same thing, period. Um, Amplitude of a periodic function is defined as the distance between the maximum and minimum values of the function. Generally, you can find a middle line that cuts the graph symmetrically and measure the height up and down from that. So I've done a little bit of work in anticipation of this lesson. I've taken a look at the first graph and drawn in the amplitude and the period. So the amplitude is equivalent on height and depth, trying to figure out where that midway point is. This graph is concentrated on the x-axis, so it goes up 10 units and down 10 units for an amplitude of 10. The period is the length of time it takes to complete one cycle, so one up and one down is defined as the period. In this case, the period is 8. On the graph that's below, it's kind of an interesting graph in that it's not symmetrical about the x-axis. So I want to figure out where that is. That's at 6 and that's at -2. So that's an overall height of 8 units, which means the middle of this graph is technically at 4, so that I can take my 8 units and split a height of 4 and a depth of 4, which means I'm going to go at 2. So at the y value of 2, I can see a height of 4 and also a depth of 4. So my amplitude is 4 and my period. I need to figure out what my period is. Figure out when it starts and stops along that line that we've identified. So I've got a start and stop there and a start and stop there. So I'm looking at going from 2 to 7, roughly, or 1 to 7, roughly 1 to 7. So the period is from 1 to 7, which is a period of 6 units along the x-axis. We've got an interesting graph below. If you're in robotics, that's called a pulse width modulated graph, but we're not going to worry about that one. Turn the page over. In the presence of some students here this evening, I figured out the table of values from 0 to 360. So I used the table setting. I entered y1 as sine x, so I'm in degree mode. And my change in my table, my change in t value for my table set is 30 degrees. So I can get a record of my table of values. And I plotted those points in green. Those points form the basis of my graph. And then I'm actually able to extend the periodicity of the graph to see that this pattern continues both forwards and backwards. And I've drawn that on the blue lines. So from 0 to 360, I've got dots, which correspond to my table of values. And then I've extended the graph following the pattern that was suggested. So sine x is a periodic function whose graph continues indefinitely to the left and to the right. We built a graph or a table of values on a restricted domain, just going from 0 to 360. Domain and all those other excellent words. Domain, x's and elements of the reals. Amplitude is 1. It goes as high as 1 and as low as -1. My x-intercepts. My x-intercepts are an interesting value. They are multiples of 180. Can I write that in a bit of a different way? We'll think about that in a minute. My range from -1 to 1. My period, it takes 2 pi. I want to keep that language fresh, or 360 degrees. And my y-intercept is at 0, 0. So maybe a nicer way to write our x-intercepts. So my x-intercepts are 0 and 180, and then multiples of 180, where n is an element of the integers. So that means my integers are my natural counting numbers, 1, 2, 3, and they can be negative as well. -1, -2, -3. That's where I would get my x-intercepts from. So now we have to expose ourselves to graphs of trig functions, sine, cos, and tan, in both degree and radian. Please use your graphing calculator as an aid. Draw sketches, take into account domains and ranges. Are you working in degree and radian mode or radian mode? So we've got time today to build our graphs, perhaps catch up on lesson 3, 4, 5, and do lesson 6. By the time I see you tomorrow, we're doing lots of work in graphing, so I need you to have lesson 6 done. Thank you.